Dear student, today we will explain why radiologists or pilots wear red goggles in bright light. Radiologists and pilots, they work in dim light. So they are advised to wear red goggles whenever they will come to the bright light, so that when they will go back to their workplace, the dark adaptation will take less time. So now we want to know what is dark adaptation, what happens during dark adaptation, and why the pilots and radiologists are advised to wear red glasses or red goggles when coming to the bright light. If a person stays some time in bright sunlight and then moves into a dimly lighted room, he or she experiences a temporary blindness. He or she will not be able to see initially. That improves after few minutes. During this time, the eye adjusts to the low level of illumination, and this adjustment is known as the dark adaptation. We know that during dark, when we come from light to dark, there will be so many changes. There will be dilation of pupil. In addition to that, there will be dark adaptation, and the time required for this adaptation it may be up to 20 minutes. In dim light, the pupil dilates to allow the maximum possible light through the eye to have optimal vision. Now we want to know what is the mechanism of dark adaptation. What happens when a person moves from bright light to the dark area? So what are the changes that happen? There will be two types of adaptation. One is the neural adaptation, another is the chemical adaptation. In the neural adaptation, at the first phase of this adaptation, there will be decrease in the threshold of the cones. In the initial 5 to 10 minutes, there will be decrease in the threshold of the cone. From this graph, we can see along the x-axis, it is here it is plotted the time in the dark in minute, and along the y-axis, the intensity of light is plotted. So in the initial 5 to 10 minutes, the threshold of the cones will be reduced, and this reduction will increase the retinal sensitivity up to 100 times. The second phase, the threshold of the rods will be reduced, and this reduction will take maximum in about 20 minutes. And when the threshold of the rods are reduced, the retinal sensitivity will increase about 1000 to 10,000 times. As the rods are sensitive than the cones in the low level of illumination of the darkened room, now visual capacity in the dark room, it depends mainly on the rods. Now the second type of adaptation is the chemical adaptation. In the dark, there will be regeneration of photopigment rhodopsin. When the person was in light, this rhodopsin will be converted to the all-trans retinal. Now this all-trans retinal and opsin will be separated. And now when the person is again moving to dark, so this all-trans retinal has to be reconverted into the rhodopsin. And rods cannot respond completely again until the rhodopsin is restored to its resting state. And this process actually requires several minutes, during which the level of rhodopsin rises, increasing the sensitivity of the rods proportionately. So we know that in the retina, these rods are mostly located 15 to 20 degrees from the fovea. So this is the fovea centralis at the central part. The rods are mostly located on the lateral portion or peripheral portion around 15 to 20 degrees from the fovea. The dark adapted retina is most sensitive to light in these regions. So dark adapted retina, these peripheral regions, they are most sensitive to light. As a whole, The dark adapted retinoid is around 10,000 times more sensitive than the light adapted one, because during this dark environment one has to see certain objects. So it has to be more and more sensitive, and these rod areas are very sensitive. And for this recovery of the rhodopsin, or for the resynthesis of this rhodopsin, so we require vitamin A. And vitamin A deficiency, we know that this will adversely affect the dark adaptation ability, and this condition will result in the night blindness. Now the time taken to accomplish full dark adaptation, it depends on certain factors. So how long it will take to get dark adapted, it will depend upon the intensity of light you are exposed to, how long or duration of time you are exposed to that light, and the wavelength of light to which your eyes are exposed. So intensity, wavelength and duration of light, these three factors are very important to determine how much time will require for the dark adaptation. If the light was very bright and if the eyes were exposed for a longer period of time, so the dark adaptation requires longer time. Now the question comes, why red goggles? Now the red color, this red light, they have the longer wavelength. We can see here from this chart, the red colors, they have the longer wavelength. Now they have a special quality. They will stimulate the cones to a fair extent. So longer wavelength the light, so it will stimulate the cones to a fair extent, but rods are relatively insensitive to it. So that is very much important. This longer wavelength lights, they will not stimulate or less stimulate the rods. They will less bleach the rods. The aircraft pilots and radiologists, they work in the dim light. So when they will come to the bright light, they are advised to wear red goggles. Because if they wear the red goggles, their rods are less bleached and their sensitivity is maintained. So when they will go back to their workplace, they will again enter the dimly lit room. They do not have to wait for 20 long minutes, as rods are soon dark adapted. That is the reason these radiologists and pilots, they are advised to wear the red goggles. It explains why radiologists and pilots are advised to wear red goggles when they come to the bright light. Thank you and subscribe. So this is a reference.